but let's get started. So a bit about myself. My name is Shao. I'm a senior software developer, but lately I'm being more into business since I founded several startups and especially in software and AI recently. So I've been building AI application myself, and such as Mail Magic and Athena AI and Athena Whiteboard. So yeah, and let's get started. So before I get started, I want to see what's the level for of the audience over here. I assume you guys all know how to write a prompt, right? So I don't need to go over that. Have you guys ever used RAG in your application or fine tuning? Okay, okay, not that many. So let's go over the RAG and fine tuning parts. For if you guys have a more question, you guys can ask me in the end. Yeah, so I mean the easiest way to show some guidance to the language model is using few-shot learning. I wouldn't call it training because that's some confusion. You are not really training the LLM with your examples. It's more like provide the language model with guidance, because the language model is already trained over like 1 billion data points with across industries, right? So what you really are telling the model with your few-shot learning example is to, this is what I want. I want something like that. Can you give me something similar, right? It's more for guidance rather than training it. So here I have my example over here, right? If I'm asking to write an email reply for a follow-up email for a conference such as ConFoo, then I can few-shot a few examples like this. It was, okay, please write me a reply to the message. I usually reply like this, right? 1, 2. Very simple example over here. Yeah, of course, let's get into the more relevant topic for today. So in order to further optimize your LLM application, you either need to do some fine-tuning or retrieval augmented generation, which is RAG. So yeah, we'll go over the pro and con for each technique. I think these days, I'd say in general, you use RAG more than fine-tuning, because fine-tuning is really resource intensive, I'd say. And yeah, so let's check, let's get started on that. So first of all, for fine-tuning, it is only useful if you want more consistent output. I think one misunderstanding that I see from other AI startup founders are they think that fine-tuning can make the model smarter, which is completely false. If the problem is complicated enough that the model doesn't understand it, you won't understand it better with fine-tuning. So fine-tuning only make sure the result is more consistent. For example, if you have a very structured output that you're expecting, such as you want a yes or no answer, or you want a superstructured enum-based answer, then yes, you can fine-tune the model so that you hallucinate less. You output the consistent format more frequently. So that's, I think, the only advantage of using fine-tuning. So, of course, there's also the advantage of shorter prompting, because you don't need to put as much information in your system prompt compared to a fine-tuned model, in your fine-tuned model. So, yeah, I already talked about the challenge with fine-tuning. Very time-consuming to gather the data. You usually need a significant amount of data for it to be effective. You cannot just few-shot 10 examples. So, oh yeah, another thing that some enterprise may be concerned about this data privacy issue in case you train with real users' data, because then if you use the model and the model can output to other users, you use the data from one user, you may output the information of that user to another user. So you need to pre-process the training data before feeding that to the model. So again, it's more time consuming. And like I mentioned before, it doesn't really improve the strength of the model. So if the model doesn't understand how to solve this problem, like it would not be stronger after learning your examples. It does not like improve the strength of the model. Another thing about it is more in the industry is usually fine-tuning is only available for the weaker models, for the smaller models. They are not available on the latest model. So by the time you fine-tune your own model with fine-tuning, then a better model came out, and you can perform better than your fine-tuned model, depending on the use case, of course, but that's what we find for our application. So that's why we stopped doing fine-tuning for our use case. I'm not saying it's the case for other applications. We did fine-tuning for some of our application before, but not this year anymore. So now ideal for small businesses. So then, yeah, let's get into retrieval augmented generation. Oh, question?
Just quickly, what would be a good use case for fine-tuning?
I can go over that, actually. I will go over that with an example, actually, so afterwards. Yeah, so for the retrieval augmented generation, which is RAG, is a much more useful way of getting external data, since what you do is, there's many ways of doing that. You can do it through embeddings. That's actually the most popular way of doing it with unstructured data. So you turn any kind of unstructured data into embeddings, and then you do like semantic search over it. No need training data. Work with all the LLMs, not just OpenAI, right? You can use Anthropic, you can use DeepSeek, you can use Grok, you can use Gemini. It doesn't matter, because you essentially feeding the process data back into the prompt to augment the prompt. So yeah, let's go over vector embeddings very briefly. This is the case where you're doing the RAG with unstructured data. So the way it works is you turn that unstructured data, can be like PDFs, web pages, CSV data, and any kind of data. You can turn that into vector embedding, and then also you turn the user's query into embeddings, and then you do a semantic search over the data source, which is unstructured data, and then you do something with it, extract it, and feed back into the prompt. So more precisely, this is how like a basic RAG pipeline looks like. So basically let me just go, I think, like I said before, this is a vector database. I think this slide's over here. So once you have the match, once you using the semantic search, once you have a match between the user's query and the vector database, you have the embedding stored in your vector database, then you can do something with the data and push that relevant data back in your prompt. You can make it as extra information in your prompt, or you can use that as few shot examples. So again, like if you want to host embeddings in your production environment, you would need a vector database, such as PyCon. There's other ones as well. There's a bunch of them. But yeah, PyCon is a very popular one, a dedicated one for that. If you already use Postgre or Redis, they also have their own like vector database plugin. I think we use PG vector for the Postgre for a while. So let's go over the, so an application that we built using RAG pipeline, especially early on, is called Mail Magic. So I can go over how we did it. So basically, the RAG pipeline for that is we read whenever a user connect with their inbox, we read their past email and convert them into vector embeddings and store that into our vector database. Whenever there's an incoming message coming in, that's kind of the query. We also turn that into vector embeddings. And then we run the semantic search to extract the matching vectors, the matching documents. Then from the matching document, we find the past response that the user did, extract that as few-shot example, and feed that back into the prompt. So how does that work exactly over here? So for example, on the left panel, let's say I receive email like that after ConFoo saying, okay, yeah, nice meeting you, what do you do? And then Mail Magic would turn that into a vector embedding, and it would look for similar message in the past. And usually, the specific way we engineer that is we only turn the email that I sent into embeddings, because it also includes the thread, the historical thread down here. So we don't need to turn the entire inbox into embeddings. We only need to turn the send messages into embeddings. And usually what the matching does is you match, as you can see on the right panel, the message on the left panel is very similar to the original historic message in the right panel over here. And above that, since it's in my sent inbox, it has my past reply. So I can easily just use some Python code to extract from that document, extract what's on the top. Then I can just grab those messages as few-shot example and feed that back into my prompt. So that's how we did our augmented generation. So yeah, like the gentleman said over here, I asked earlier over here, what's a good use for fine-tuning over here? So we realized that when we run the RAG pipeline, usually it works kind of like most of the case where it's for customer service emails. So if you only require your email having information, the correct information, then RAG is fine. Retrieval RAG is fine. However, if it's someone you know and you want to reply, but they would also want to reply in a tone that they realize it's you, not the AI, then it's more challenging with RAG, because all RAG does is it grabs the information. You can tell the model to answer in a specific tone, but from the message we generate, we see that you cannot match me. Like the word, if I need the exact wording to be like me, then I need to fine tune with my own message, my own messages. So for example, often what the RAG, only using RAG, the message always starts with something like, thank you for your message, thank you for clarification. Even if you say in the prompt that don't say that, you will say that, but in a different way. So that's why I think this is a good case, and we did that with Mail Magic. This is a good case for fine tuning. Yes.
would you explain for the audience what's the link between the vectors and embeddings? Well, because most people don't understand what embedding is and how they're linked to the vectors.
Oh, okay. Well, basically, you kind of, in a more high-level explanation, is you turn the data into like embeddings, right? And then you perform the search. The search usually is you call like a API to perform the search. What usually does is some kind of like distance computation, right? You compute the distance between like the vectors, which is like the dot product of the vectors. And then on that, you will find the closest match. Essentially, that's like, if you want to explain that in a few sentences, this is the very brief explanation. So yeah, now let me also go over retrieval with structured data. So the retrieval, we saw the retrieval with unstructured data, which is, in my opinion, the most popular. It's probably the one that you heard the most, turn things into embeddings, and then do search this way. But yeah, now, if you already have a very structured database, and that you can run a query, a filterable query on, well, I guess you guess what? You don't need to turn them into embedding and search them with like a vector search, right? So you can just search directly, right? You can just perform a search directly on your SQL database or your Mongo database, right? So I saw a lot of, as a startup founder, I'm very active in the founder community, and some of the startups, what I saw they did is they already have their database. They turned that into embedding, into vector database, and they did a search like a vector search. I'm like, why you need to do that? You don't need to do that, right? Like, what are you doing with your embeddings other than doing that, doing the vector search? So yeah, so if you, I'm going to go over an example, that's for sure. So yeah, the advantage of retrieval with structured data. Oh.
Sorry, but with structured data, when you have texts in your database, when you convert those texts into embeddings and use vector search, you would get significantly better results, because anything you can, the most you can do with SQL structured data is fuzzy match.
Yes.
But fuzzy match is pretty bad on vector comparison, while with the embeddings you would definitely get significantly better answer in terms of the output that you're searching for text specific.
Yeah, exactly. If you have like text, which is again structured data, then it's always useful to do like a vector search, right? So, but I'm saying that if you have very specific query, I'm going to go over an example on why for this specific case is better. But yeah, let's just go over the example. Let me just go over. Yeah, so no need to maintain embeddings. No need work with your existing database. And more accurate retrieval if you can do very specific query. I'm going to through the chess example to show guys why. And of course, like you say, like this gentleman said here, it's not always doable first. And yeah, you need very filterable data to do that well. So let's just go over an example that this technique can work well. Any chess player over here? We don't have a lot, but I assume everybody know how the rule of chess, right? So like opening, there's certain opening. Yeah, in my example, I even pick a very known opening, which is Queen's Gambit. You guys saw the TV show, right? So so like let me go over why in this case it is a very good use case. First of all, I'm a chess player. I have an ELO about 1800. I played tons of tournaments when I was in high school. So I'm a bit biased when we added this feature in our chatbot to recommend chess puzzle, is because I like chess a lot. So, but what I realized that it's a very good use case for doing retrieval without embeddings, because first, chess is a very popular game, so you don't really need to tell the language model what is chess. They know chess probably more than you guys and more than me. So it's at least like the information about chess, not playing chess. That's a different story. And also chess has a very like structured like data. So the ELO system is very numeric. So you can query by numbers, right? So, and also the chess theme is basically the opening tags and also the puzzle themes are basically like enums with a finite set of enums, right? It's a finite set of like tags. So yeah, in those cases, the data is super structured. There's no like ambiguity in the text. So all you need to tell like I'm just going to the next slide over here. So all you need is just having like a reasoning chain that makes sense, that first asks the language model to generate the query. And to do that is retrieve in your system prompt, you retrieve all possible themes and opening tags. I counted that. That's, I think, less than 2,000 of them. So it's not much for like the modern models because they accept up to like 2 million context window. And if you only have 1,000 tags, usually they can, usually it's not a problem for them. So yeah, and then you describe the database schema with details. It's kind of a mini documentation that you tell the model what the database schema look like, and then like the model would understand how to generate the query for you, right? So then you ask the AI to return a DB query based on the user's prompt. So for example, in my example over here, I can ask the user prompt here. I play Queen's Gambit. I need a difficult puzzle on middle game kingside attack. And from this query, what the AI would generate is, you understand what is Queen's Gambit. I don't even need to tell it that Queen's Gambit is the chess opening. It knows it right away. So it will generate this filter on the opening tag filter. And when I say it's a difficult puzzle, by meaning the keyword difficult puzzle, it knows the ELO system very well, the chess ELO system very well. So from that, you will generate a filter on greater than like 2,000 ELO, for example, here. And then and also the middle game kingside attack, those can be like 2 different theme tag, middle game and kingside attack. And this already is a very complete like queries for me to recommend the correct puzzle over here. And once you have the query ready, you can just run the query, and you will return the correct puzzles. And sometimes what I find is if you have if the query is vague and not specific like that, then you can use another prompt to like post-process again to select the most relevant puzzle according to the user's query. So that would slightly improve the result. And also it depends on if you only want one result or you want multiple results. Oh yes, so yeah, that part. Yeah, so I haven't tried that yet, but I believe like it's also good to, in terms of fine-tuning, it's since we talk about fine-tuning, probably on when it's generating the query, sometimes it does hallucinate and generate like a bad query or query with some extra text or something. Sometimes it just generate something completely irrelevant. So yeah, in this case, fine-tuning may help on that to produce again more consistent result. Because here for the MongoSQL query, is a very specific output. And, oh, go ahead.
In your experience, would fine-tuning be a best solution for filtering, for example, inappropriate content, like, for example, sexual content?
No, I wouldn't, because fine-tuning is really depending on the data you train on, right? The data you fine-tune on. That's actually a good question. My other project is related to that. So my other project is it's called Fan Story, which is kind of like it's a monetization tool for content creator. And the differentiator we have over here is, like we differentiate from OnlyFans. So yeah, we actually have something for that part. Yeah, and what we find is you just need to be very specific in the prompt. That's it, and that's good enough to let it not generate like not safe for work content. Yeah, and yeah, so this is a showcase of the query I just talked about, right? I play Queen's Gambit. I need a difficult puzzle on the middle game kingside attack. And you just give me a puzzle over here. Anyone can solve this puzzle? It's a quite difficult one, I'd say. If I checked the rating on that one. It's around 2,000. So if you guys know about chess, 2,000 is about the expert level. What is it called? The expert level. I'm not at that level yet. So yeah, so that's pretty much it. Let me know if you guys have any question, either it's on the AI itself or on AI startups. Oh, go ahead.
Also, you've made a comparison between fine-tuning and RAG. Can you do a comparison between fine-tuning and prompt engineering?
Fine-tuning and prompt engineering?
Because like the example you put in, like I want my emails to have this tone.
Mm-hmm.
It seems like you could have the same result with prompt engineering, or am I wrong?
Yes, not really. Like you can ask you can write the prompt saying don't say this, don't say that, or say it in the specific way, but it doesn't have the specific wording. Sometimes it's very difficult for the language model to have the specific wording combination that you want. So it's important for it to see the examples that you want, right? This is a very specific case that I really want the output to sound like me. It can be good saying like if I ask to be straightforward, for example, it can be like straightforward. Instead of outputting me with 10 sentences, it gave me 3 sentences. Yeah, but yeah, like but with fine tuning, the choice of words can be very precise. I think I mentioned over here in my example here. Where is that? Fine tuning. I think I mentioned it somewhere over here. Oh yeah, exactly over here. So you see like this difference, right? Like when I say straightforward, I'm not saying 2 or 3 sentences. I'm straightforward. Like please let me get back to you shortly, right? This is it may sound very simple for a human, but yeah, it's difficult for the AI to sound exactly like that, right? So, and if I say it sounds exactly like that, then under some different circumstances, like I need flexibility, right? So.
Let me expand on this question.
Yeah.
You talked about fine-tuning on the output of the AI.
Mm-hmm.
What about fine-tuning on the input, where the prompt is, you can do the fine-tuning there?
Oh, yeah. I think that's called the prompt optimization, right? The prompt validation, evaluation. That's a completely different topic. But yes, but that's like, I can give another 15-minute talk on this topic. But yes, it's like, but yeah, that's a very popular topic as well, where you can optimize. There's a few ways to optimize the prompt. I can include, maybe I can include in my slides some link to that. I think Google run, like since we're in the Google for Startup AI program, they have their own optimizer that they want us to use. And, but in general, like a very simple way of doing that is you can force retry. I think OpenAI, like I think most API actually support that. You can force retry if the output is not ideal, and then you can force retry, and you can even do like kind of a unit test, right? You prepare a data set, and then you run the prompt on that, and you evaluate if like how the prompt perform over the data set, right? So yeah, I can send the link. In fact, I just attended another startup's talk where their project on GitHub is actually addressing this issue. They have a more advanced way of doing that. I can also share that in my slides afterwards. Yes?
Are you using any tools to validate or just collect data on all the conversations that you're having with like all your traces, sorry?
Oh, you mean, yes. We used to use LangChain for the
I meant like observability tools in general.
observability tool. No, we're not. I need to ask my team, but maybe some of them are into that. Right now, like I'm less involved in the day-to-day of the backend these days because I'm mainly running the business. But yeah, I can check that, and if I find something, I can also include that. Yeah, go ahead.
So this is all new to me, but like generating as a backend developer, like asking the LLM to generate a SQL query, an arbitrary SQL query that I'm going to run against my DB. It sounds a little worrisome. Like, what are some of the ways, besides fine tuning to make sure it doesn't hallucinate and produce garbage? Like, what are some of the ways to make sure that the SQL query that you're going to run is going to work?
Yeah, exactly like this gentleman mentioned. We're here. The prompt validation and evaluation would solve this issue. Yes, it's kind of like a running unit test, like against your prompt to see like how. Before deploying that. Yes. Yeah. Yeah.
One good tactic there is to collect a good list of bad queries.
Yeah.
Put this as a filter of the output of the AI, and then
Yeah.
ask the AI to compare if the output from the AI is matching anything within the filter of queries. If it is similar to that, it can decline it and try again.
Yeah, and also you can use negative prompt, right? Not only tell what's a good thing, and also what's not good. So you can, yeah. Go ahead.
So one question about your email body generation, right?
Yes.
So for example, if you write the emails as technical lead and then you get promoted to CEO, for example.
Yes.
What would be like the best approach to train your setup to start creating emails as a CEO instead of a technical lead? How would you go about this?
Well, like since the language model usually already know how a CEO roughly answer because it's trained on like a lot of data before like your own data set, right? So yeah, like roughly like it knows already how to do that. So that's why I say like if you wanted to behave specifically like this person, then you may need to fine tuning. But if you just wanted to behave like a generic CEO or generic accountant, yeah, fine tuning is absolutely not necessary.
So in the business, for example, the Mail Magic, do you use the output of the model to retrain the model in the long term?
Output of the model to retrain the model, yes.
Emails generated by the model, would you use those?
Yes, exactly. Remember, every time I send an email, that email became past email. So we do that.
And do you find that it converges into specific patterns?
It converges, no, like Like, what do you mean by specific pattern?
So essentially, you're training with synthetic data.
Yes.
Have you observed any long-term effects of training with synthetic data?
Not yet, but also, like there's not that many email per inbox, right? It's not like everybody have a million data. So yeah, like we haven't noticed that yet, but yeah, we're keep monitoring that. And we also only do that for specific inbox. This is not something that everybody can turn on, because it has to be very specific on that person's data. And also, it doesn't make sense to train they train the model on multiple people because of privacy issue, right? So yeah, go ahead.
So in my team, for example, if we wanted to start using RAG
Yes.
in our everyday experience, what would you say about investing in implementing RAG versus, for example, just going simple and working with the prompt and providing context as part of the prompt? Do you think this approach is much simpler for teams starting using it?
Yeah, I think so, because it's very simple to just dump everything in the prompt, right? You don't need to set off you don't need to do like complicated setup that such as a vector database, embedding, and a whole data pipeline for that. If you don't have a lot of data, I think, yeah, just dump everything into the prompt as your minimum viable product. And then from there, see if it makes sense to do RAG with fine tuning afterwards. And especially right now, you have like, if you use Gemini, Gemini accepts 2 million context window. And also it's fairly, if you're an AI startup, it's fairly easy to get credits from Google for Gemini. They provide 25K credits if you're an AI startup.
Just to make sure I understand that answer correctly, so in the case of MailMagick, for instance,
Yeah.
instead of using RAG to retrieve just the emails that are like reply to nice to meet you at the conference,
Yes.
you would dump all the users' emails in Gemini, for instance.
Yeah, it will perform less well though. So like if it is too many data, because what the retriever does is not only I retrieve the relevant document, I match exactly, let me just, oh, the mic is getting loud. So I match, you see like here, I'm not even retrieving, I'm not even pasting the entire document, I'm pasting those as few shot examples. So it's a very precise way to engineer the prompt. Not only I did the RAG, I retrieved the document and paste. I'm not just pasting the entire document into the prompt. I'm actually fetching that specific information above over here, not the one that I circle over here, but the message above over here, and use that as few shot example. However, what you can do is, if the model is strong enough, you can do in multiple steps, right? So you can say, okay, this is all my email, and please extract this part, and use that like as few shot example for my next prompt. Yeah, if you have a stronger model, yeah, you can do that. It will still like not as precise if you compare to this way but it's a good starting point. Yeah, you can always like break a bigger problem into smaller problem and use like a prompt for each one of them.
And could you provide some wisdom about testing, like a sort of like unit testing, but for this kind of technology?
Yes, like the gentleman said over here, like yes, there's multiple technology that that is doing that. Let me see if I can find. I think I shared something with someone very recently. Let me. I'm for sure. I'm going to include that. There is. Let me see if I can just Google, because the tool that we're talking about here. Okay, yeah, I find it over here. Let me. Mirroscope, yes. So for example, this is a very good one. I can include that. This is co-founded by a group of ex-Google engineer, and yeah, LLM abstraction. And they have several toolkits for that, for prompt validation, annotation, evaluation, and also, yeah, testing. So, yeah, I attended some of their talk in Los Angeles 2 weeks ago. So, yeah, this is a very good one. And of course, like all the, Google has their own optimizer here. If I just search for, yeah, I need to go to Google's here. So Vertex AI. Have you guys used Vertex AI from Google before? Yeah, so Vertex, they have the optimizer, I think. Yeah, here. I think it's fairly new because it's under preview. So we're looking into that one as well because Google is pushing that for all their AI startups. Yeah, this has a very detailed documentation on how you can do that. Any other questions?
You mentioned a few vector databases in your slides. Can you compare those with Apache Sword?
I haven't used Apache Sword though, so yeah. Again, let me see if some of our engineers try that. As I mentioned, I don't involve in the day-to-day operation of the dev part of things anymore. So some of the newer technology, I may not be aware of.
That's very old.
Yes. So, and some of the comparison, let's say, right? So, with the newer technologies. So, any other questions, guys?
Just one more question.
Sure.
So for RAG, you have your, you need to choose your LLM first. And then I know for the LLM, you can choose for a bigger LLM.
No. Like for RAG, oh, he's ending. Okay. Maybe we can talk afterwards. I think he's ending here. Yeah, feel free to talk to me as I wrap things up because I think the next talk is coming. So, thank you guys. Thank you for coming.